Welcome to Portfolio Stories, Science and Success, a podcast where we explore inspiring journeys, groundbreaking research, and the people shaping the future of science.
We are back from the Congress with Dr. Aleksandra Badura, Associate Professor and Lab Head in the Department of Neuroscience at Erasmus Medical Center in Rotterdam. Her lab investigates how the cerebellum shapes behavioral flexibility and how its dysfunction contributes to autism spectrum disorders. Dr. Badura is also a close collaborator of Łukasiewicz Port through the same NeurID project. Thank you very much for agreeing to be with us here today, Ola.
Thank you for having me. It's really lovely to be here, and I'm also really enjoying the conference.
So I will start by asking you a little bit about your research pathway. So can you tell us how you ended up studying the cerebellum, and at what point did you want to be a scientist and lead your own lab?
Let's unpack it a little bit, because actually I'm a little bit nostalgic, because September marks 20 years since I left Poland. So I left Poland in 2005. I did my master's in psychology at Jagiellonian University, and I decided that for the master's thesis I wanted to do something more neurophysiological. I was back then very interested in sleep, and I approached my promoter of the master's thesis, Professor Przewłocki, and I said, I'm really interested in sleep, and is there a possibility to study it? He said, well, not really, not in my lab, but I know I have a friend in Nijmegen and Radboud University. So if you manage to get this exchange fellowship, Erasmus Plus, back then it was, I think, Erasmus Mundus, and I think it's now called Erasmus Plus, then I can write you a letter of reference. So indeed, I applied, I had good grades, so I got the fellowship. And as promised, he recommended me, and I did manage to do a little bit of a sleep study. But very early on, I switched to study epilepsy, and I stayed in that lab for around a year, first as a student assistant and then as an analyst, as a technician, looking for PhD position. And I have to say that the moment I saw the brain activity, so we were implanting EEG electrodes, and looking at the rat activity at the same time. And this was very involved because there was no deep lab cut. There were no automated ways of studying the behavior. You would sit there, the EEG would be, on the screen. You would observe the rat, and you had a box. This is for all the students here to tell you how old I am. There was a box that had 4 buttons, and as you observed, you would have to push the button if the rat was walking, if it was stationary, or if it was falling asleep, or if it was grooming. So I had to push these buttons so that we can align behavior with the EEG. But the moment that I saw the EEG change as the epileptic seizure happened, I was completely hooked to it. So I was like, wow, this is really, we can observe the brain in its activity, how it's linked to the behavior in health, but also in the disease. And this is where I decided that I really wanted to be a scientist. I actually had another job lined up in Poland that I gave up. This was in more like HR type of setting, because, from psychology, this is where I thought my path is going to take me. And ever since, I was really hooked. And cerebellum, I actually stumbled upon, because back then I didn't really know what I wanted to study. What I did know is that I wanted to go in a lab that did like top-notch electrophysiology. So I ended up in the lab in Rotterdam, and our department is known for cerebellar physiology. But when I gave a talk, I was talking about epilepsy, and we put reference electrode over the cerebellum because we were recording from the cortex and hippocampus. And so I was like, la la la, and the cerebellum, yeah, but it's not that important. You can just put an reference electrode over it. But I did get the job. So this is how I ended up in the cerebellum. And then I really fell in love with it, in the structure, function, the connectivity, and so this is how that journey started. And becoming a PI, I don't think you really know you want to do it when you start a PhD. I think that you really develop it over the PhD, and particularly the postdoc. I think it was really towards the end of my first postdoc where I really felt like, okay, I'm ready, I can do it. I think I'll be good at it, because this is also when you start to really mentor other PhD students and master students. And I always enjoyed that part. This is, I think, the part that I mostly enjoy. And this is where I thought of like, okay, I really want to have my own lab.
Okay, so your lab now investigates the cerebellum and its contribution to behavioral flexibility, right?
Yes.
So what have some of the most striking insights so far been found? So, and how does this cerebellar circuit shape cognition and social behavior?
Again, a huge question. I think the last 10, 15 years have taught us a lot about the cerebellum. First of all, we now know that this is not purely a motor structure. The most striking thing, I think, is still the work of my own lab, but also many other labs, many contributors. And this is one of the things which I really like about this, is that it's had been reproduced, is that if you induce an injury to the cerebellum, if you perturb its function during development, you're actually not perturbing only the function of the cerebellum alone, but you're changing the way that the connectivity between the cerebellum and neocortex is shaped, and that in turn causes the disruption. And I think we're really starting to untangle all these circuits, and this is a work of people like myself and others who are in translational neuroscience, but also a lot of systems neuroscientists who really understand the connectivity. So I would say that this is the most striking, to see that particularly the lateral cerebellum, that the lateral cerebellum is really very much involved in cognition, and it's sort of guiding this incidence detection. So like if you have two things happening at once, the cerebellum is very good at saying like, okay, this happened now coincidentally, you should ignore it or you should not ignore it, you should pay attention to it, because something is expected or unexpected.
Oh, I see. So how do you see this knowledge informing potential interventions for therapeutic strategies in the future? I know you're focusing on autism spectrum disorders right now, and I think there is a pretty high incidence, as we
yes
I wanna at the conference as well.
Yes, I do want to clarify two things. First of all, I think that and also I'm being very careful now to say autism as a condition, not an autism spectrum disorder, because the disorder always implies a deficit, and this is something that, working closely with the autistic community, I now understand why they do not necessarily want to be seen in that light. So even though ASD is still an official diagnosis, the field is more and more switching towards just using the word autism. So this is the first thing, and this is also how back a few years ago in literature I would say ASD. Now I only say autism. Second of all, my lab is actually not interested in treatments, because I think that as autism on its own, it's a neurodivergent condition, and a lot of individuals with autism really need recognition and support, and that they can really thrive and have a very good quality of life. We're very much interested in earlier recognition, so diagnostic criteria, particularly for girls and women who are mis- and underdiagnosed. And this is where I see cerebellar function, particularly sensory motor skills, and the dysregulation of the sensory motor skills or delayed learning of the sensory motor skills as a potential pathway to accelerated diagnosis and faster access to care. When it comes to treatment, because my lab also works with a pharmaceutical company, we really look at coexisting conditions. So autism very often comes with particularly level 3 care autism, where we're talking about also known genetic mutations that lead to autism. They also very often cause intellectual disability, epilepsy, and can also cause quite severe disruption to the quality of life, like aggression, autoaggression. And these types of behaviors, that is where I see maybe some potential for treatment. So of course for that, we maybe in the future it's more things like TMS, transcranial magnetic stimulation. Particularly for epilepsy, I think that cerebellum is a very interesting point, because there is data to show that if you disrupt cerebellar nuclei, you can actually disrupt the seizure as it's ongoing. So that could be something. But I don't want to be very clear that this treatment is for coexisting conditions and not for autism as autism itself.
I understand. Thank you very much for clarifying that. I think that most of our audience wasn't very aware of the different sides of autism.
I think it's really important because it's such a large spectrum that you have people who are who, as I said, just need some support, and some that. So I study in a lab very often so-called syndromic autism. That means that it's a monogenic loss of function mutation that leads to these symptoms, but also had all these other symptoms that coexist with it.
Okay, I understand. So I would like to switch a little bit the topic from research and ask you about how is it to be a woman scientist in this environment in the Neuroscience Society that has traditionally been perceived more of a male-dominant field, right? And how are you seeing this landscape?
Again, changing, and for the better. I think it's a very exciting time for us. I see more and more women also in high power positions, and that is every time I see someone becoming, the department head or the director or a full professor, a female colleague, I really always let out a cheer, because that means that the pathway for the rest of us and our mentees is easier. But it hasn't been easy, and particularly also the cerebellar field there's still, I would say, way more male full professors in the field than females. And you do sometimes have, I wouldn't say that there's like an open sexism or bigotry anymore, but sometimes you get these comments that are meant as like a joke, but after pregnancy, you lose some IQ points because your brain changes. And this is said like, yeah, no, seriously, this has been said, not to me particularly, but I was in the room when this was said to another female scientist who was pregnant at the time. And I was just like, you cannot say
yeah,
this. Oh, but it is a joke. And, there was this thing. I was like,
yeah, not the right joke to a pregnant woman, right?
Yeah, and when I got my grant, when I got the VD, which is like a Dutch starting grant from NVO, I was told to my face by one male neuroscientist, like, well, good that you're a woman, because, you get extra points. And so it's good for you that you got implying that I get this grant because I'm a female, not because I do
the science.
Yeah, so, but it's getting better. There's more of us. And I think that it's also, there's less room for approval or even silent approval of these types of comments, but there's still some work to be done.
So in addition to that, you are also leading a research lab abroad, right? So how has that been for you? Have you had any challenges or advantages, or how is it to lead a lab in a foreign country?
So I left Poland as a master's student, and my whole scientific career has been built abroad. So I almost regard the Netherlands more as coming back to my roots, because I did my PhD there. There are sometimes some challenges in the sense that someone could comment on your accent, right? That had happened in the past, that someone commented on my Polish accent, which I'm not trying to hide. I'm Polish. I have a Polish accent when I speak English. So when someone comments like, yeah, well, I'm from Poland, so obviously I have a Polish accent. But I have to say that I also had worked in the US, and being European and white is not as challenging as having a different ethnicity and then being abroad. So I have to say that in that respect, it's more of a, I haven't had too many challenges. But I also speak Dutch. I speak Dutch quite fluently, and that I think has helped me quite a lot to really embed myself in the institute. And I would definitely suggest that once you know where you stay and you really know that this is where you want to build a life, do learn the language, even though everybody in the Netherlands speaks English. But it really helps to connect, for example, with the animal caretaker staff or some other staff that, they do speak English, but it's much, much easier for them to speak Dutch. And then if I speak Dutch, then they can just express themselves more freely. Technical staff, etc., janitorial staff, all of the people who are super important for the functioning of the lab, not just the scientists. I think it's much appreciated to also speak the language. So that's a tip everyone.
I can relate a lot on that because I did my PhD. I mean, basically, I did all my higher education in Japan, and I learned Japanese in a few years, and yes, it really made a difference in connecting with the people. And when there is a trouble and you need some help, or when the system is not, I don't know, the way you would assume it, because, well, we have a background, so I would assume that maybe things are done in a way, and then it's different. It really helped.
I'm super impressed, by the way. I don't think Japanese is so difficult. I only visited once, and this is so difficult. The Dutch, if you speak English and German, Dutch is much easier to learn than Japanese. So
thank you. Well, I'm in Poland right now, and it seems like it's not the easiest language. So I will.
But even
before this
effort, I think this is what I was going to say. You don't have to be fluent. I had to be fluent because I also teach medical curriculum, and medical curriculum in the Netherlands is taught in Dutch. So this was also one of the job requirements. And my in-law family, my husband is Dutch, so my in-laws are Dutch. So I also wanted to be able to speak to my family. So there was also a private reason why I learned the language. But I think that helps.
Okay, so I guess I'm gonna start by making a Polish boyfriend.
Or like force your Polish friends to speak Polish with you, because sometimes they want to switch very quickly. One thing, when I was learning, like everybody wanted to help me, so they would switch to English. But then, so if you say, no, we're going to stick speaking Polish or Dutch, that helps.
Thank you. So we are going to wrap up with my last question, which is, what advice would you give to young scientists, especially women, who aspire to build a career and eventually lead their own research groups?
Yeah. We have this saying in Polish that if they throw you out through the door, climb through the window. And I have applied this my whole career. And I think perseverance. So perseverance and building networks of support. I wouldn't be here if it wasn't for the female friends that I have who had supported me all the way. More senior, but also within my peer group. So persevere, try to
make it happen.
Make it happen in the sense that don't try to not to take it personally. It's normal. You don't get the grant. You cry yourself to sleep, and then you pick yourself back up. You say, okay, what can I change? I know I can do it. And find your support network, because that's really important. And last thing, collaborate. I think that we are very, very good at collaboration. I see a lot of females leading successful collaboration. I'm leading currently a Dutch network of 20 plus partners, and this is something that I think we're really good at. So utilize this.
Thank you very much. I enjoy our conversation very much. Thank you for sharing with us your research journey, as well as all the nice advices. And we wish you all the best of success in your future projects, and looking forward to meeting you again.
Thank you. It was really lovely to be here. Thanks.
Thank you.
Thank you for watching part 2 of our special episode. Tune in for part 3